So after the previous presentations, I'm gonna try to continue a bit with that view of the renewable energy, how we foresee the future, at least, and how we are trying to cope with it in IREC. Okay. Again, I will not focus only on offshore. I will also talk about more generally renewables and their integration to the grid. Okay. So first of all, let me see if it's now. Okay, I will talk a bit about IREC. Mainly, IREC is a quite young research institution. We are like now 11 years old. Okay, and mainly our vision was to provide, some new view on research and innovation, and really try to develop scientific and technological know-how. Okay, to become one of the leading institutions within Catalonia, okay, to cope and bridge the gap between universities and really an industry. So, well, this is somehow the same. So, and we have a certain part of trustees, okay, so we are sort of partly funded by the Catalonia government, by the government Spain, and also certain universities that we have locally, UPC, University of Barcelona and Rovira Virgili, and also some industrial companies like Enagas, Endesa, which is the local diesel, and Gas Natural Fenosa. IREC has three key areas, okay, of research, which is energy and environment, energy storage, and smart energy management. And it doesn't mean that they are three different groups or areas, but this is like the concepts, okay, that we have like a pillars within our research center. Then we have different or two key research units, okay, or areas, which is the advanced materials, and then the energy efficiency systems and buildings and communities. And then I will present the research that we are being developing within three of the groups, okay, mainly the solar PV, the power systems, the one that I'm leading myself, and then the energy system analytics. Okay, so first of all, I will provide also a brief overview of what we understand that will become the power systems in the future and what challenges it will have. Okay, so something, this is a quite old figure. Maybe you have seen it, all of you, many times. But what I like of that figure is mainly that we can see, let me put the laser, that here it's clearly the European map, sort of we can really see it yet. But in the 2050, it's not expected to see it anymore, so we are not clearly seeing that there is a sea in here. So everything will be interconnected. And in fact, it will happen the same with Spain and France and so on. So everything will be more interconnected, and we can no longer talk about isolated transmission systems, but just integrated. So, and this is of benefit for the renewable energy, because at the end, we will need really to share it all across Europe. Okay, and then something that is quite relevant is that we are expecting that for 2050, we will become, at least from the electrical sector point of view, 100% renewable based. But this will bring us really lots of challenges and barriers to overcome. Okay, so first of all, it's like we need to try to know and to define what technologies will be really on that energy system, right? So we will have different type of generation, wind, solar, wave, hydro, whatever. Then different type of energy storage, batteries, also hydro and hydrogen, maybe others. And finally, we can even talk about hybrid concepts, okay? And something that also is quite relevant is that at some point, most of that technologies will require power electronics, which change the way of control and behave the system, okay? Then also we need to ask ourselves is that can really the electrical system withstand it? If we are dealing as it is now, it's very it can be expected that some support that are now being by the conventional generation will need to be provided by renewables or other services, right? So we'll need to activate flexibility, activate ancillary services from renewables, etc. And at the end, also, since we have that amount of renewables and that amount of power electronics everywhere, we will need to understand how it will behave, right? The new system. So we are expecting new dynamics, of course, less inertia. I cannot say zero, but really low number of inertia. So it may be leading us to a new grid codes, obviously to an hybrid AC-DC networks for transmission and even in distribution, and a complete global management for the cross-border energy exchange. Okay, so this is something that we will face, obviously, on this. And finally, we need to answer the question. It's like, can we really afford make that change? Um, Probably the answer is, okay, we can just put the money there and that's it. But since I think that everyone is aware that this is lots of money, we need to work really towards reduce the cost, reduce the environmental impact, and foster new business, and also try to take advantage of digitalization in order to help us to continue reducing that cost and increase controllability and observability. So, but something that is quite important also to keep in mind is why we are fostering everything to 100% renewables, okay, which at the end is fight against the climate change. So we will need even to consider the resilience of the system and how the climate change will impact on renewables and other factors, okay? Because at some point we are now rushing because the climate change is here, okay? So this is something that we cannot just forget. So what we are really doing at IREC to cope with it, of course, I will focus a bit on renewable energies. First of all, we have a specialist group on solar energy. They are mainly work on thin film technologies. Okay, so they develop different type of transparent PV for BIPV, different substrates, different technologies, and even they are now working on smart windows for PV generation. Okay, so the objective of them is try to allow the penetration of PV in the largest surfaces that we can have available everywhere. Okay, then also we have a group which is Energy System Analytics working on data analysis, optimization, and environmental impact. So mainly they are working on statistics, data visualization, optimization, on modeling, and then LCA analysis. Okay, and of course there is lots of things that we can do with that, and it's completely related with renewable energy integration, smart mobility, smart cities, and energy storage. Okay, so there is anything related to second life of batteries, energy storage integration and management, wind forecast, uh, aggregators for flexibility, energy management systems, and so forth. And then on the power systems, what we are trying to deal with, okay, is like to ensure the proper integration of the renewables. So there is lots of things that we need to deal with on this. So there is work on communications, work on power electronics and renewables, electrical network, energy storage. And of course, there is lots of subtopics that are related to it. Okay, so we can talk about cybersecurity, we can talk about controls, we can talk about resilience, we can talk about BMS and state estimation, etc. Also, something that is quite important that related to offshore technologies, for example, is that IREC also had a spin-off, which is called EOLOS. They are mainly a floating LiDAR solution, okay, and it's quite well posed lately. I mean, on the market, so they are really doing quite well. Then I will talk about some key ongoing projects that we have. Okay, one is the core wind, which is for floating wind. We are moving from, or we are aiming at 15 megawatts models, and we are considering um, two types of floater substructures, one spar and one semi-sub. Okay, and of course we are trying to integrate here anything related to shared anchors, shared moorings, integrated modeling, digitalization, digital twins, etc. Okay, then our working here as IREC, it's mainly all anything related to LCOE, LCA analysis, digital twin, integrated wind farm control, and then also the optimization of the layout. Then also we have been coordinating one Marie Curie action. okay, on control smart grids, and our main tasks were, or projects within that, was the distributed wind farm control. Okay, so how to optimize the wake effect on the wind farms in order to maximize the reserve, in order to provide ancillary services. Okay, and also how the AC/DC grids will interact. Okay, so anything related to resonances, control interactions, etc. Then we are working on the microsense project, which is about cybersecurity. Okay, so the important thing is like how the communication world is really interacting with the electrical world. Okay, since we are moving to digitalization, we are merging both, so we need to consider this as a new risk and we need to face it. Okay, so we are working on clusterization, self-healing, balancing, and then also we are the coordinators of one additional project, which is a Cobra, which is for novel batteries for electric vehicles. Okay, so the project deals with everything from components to the testing and validation of that the full battery pack. Our main task within IREC is the second life applications, it's the advanced BMS development, and also the LCA. Also on renewables, we are working on the Super PV project. Okay, Super PV is for mainly reduce the cost of everything, and here we're working on fault tolerant converters, LoRa-based communications, and dust sensors. Okay, which is something quite relevant on PV. So we need to know what is the level of dust and soiling that we have on the module. Okay, and then also the digital twin. So how we can correlate and improve the operational maintenance of the PV. Then of course we are working in many more things, new offshore wind farm designs, like DC, complete DC, non-startup frequencies, and so on. We have been working on the power smoothing for wave energy. Okay, from simulations, we have not go never on real testing of that, but how to include wave plus different types of storage in order to ensure that we are providing the proper energy to the grid. Also, how to provide different ancillary services like frequency control, how to control the multi-terminal HVDC, and then oscillation dampings. And finally, this is quite relevant, also the operating aging of the everything related to vehicle to everything. Okay, so vehicle to grid, vehicle to home, and so on from the EA. And also we have been working on the grid resilience, for example, on the climate, against the climate change. This is for flooding and how the flooding can impact on different electrical substructures. Okay, in here, so we can see what are the foreseen due to large rainfalls, what part of the cities will be in risk and how it impacts on the electrical side. Okay, so for me, this is something that is quite important, and that's why I think it's worth having that type of meetings and workshop. Is first of all that provide different points of view. Okay, so because we need, I can see it from my way because I'm working on from that for a certain time, but maybe someone starts to work on the same field from a different perspective, and we can see it differently. So I think that this is quite important. Again, since I'm only going from one goal, I cannot see the rest of the problem. So the collaboration will help us on that. So that's why I like the concept of crowdfunding of ideas. Okay, so I think that we can really enrich the research and innovation if we foster this. Then just to finish up, we have already some ongoing collaborations within UK with Orecatapult, with University of Strathclyde, and then also with Cardiff, Huddersfield, and Newcastle. Okay, and that's it.